welcome to the first video of our library series. Today I'm going to create a graphics library. As you can see, I'm rendering some shapes here. They have different colors, they are rendered correctly to the resolution, and they all work as they should. The graphics library is a set of functions and scripts that can render graphics output to the screen. Simple shapes, text or similar graphics objects are included. GameMaker Studio has its own native rendering functions, but they are problematic, so it causes less comfort during programming and doing calculations. For example, all shapes are drawn at the 1:1 with the screen resolution. These issues could be removed by scaling the graphics object you want to draw. However, some of the rendering functions do not even work right. As an example of a problematic function, I can mention the drawLine function, which doesn't draw the first pixel. These problems lead to the need to create our own graphics library. Graphics rendering are pretty much low level, so the fastest algorithms will be used to load the CPU as little as possible. If the library was slow, nobody would use it and the programmer would have to write very optimized code to compensate the speed of the library. The main advantage of the library is that every rendered pixel will be a white sprite of 1 pixel width and 1 pixel height. This will allow us to color the drawn shapes as we want, but also transform their resolution in the right way. The shapes that the library will be able to render are pixels, lines, rectangles, and filter rectangles. To render lines, I'm going to use the famous Bresenham's algorithm. Its advantage is speed and the fact that the algorithm works only with integer values. Anyway, GameMaker Studio uses only two data types, double and string, so the CPU will still take the values as float. This is a disadvantage for speed, but the positions of all rendered pixels will be aligned to integers. To render the other shapes, I have designed and optimized my own algorithms, which use mainly scaling to render shapes as fast as possible. First of all, I am going to create a new sprite and call it Sprite Graphics Pixel. I set its width to 1 pixel and its height to 1 pixel as well. Just color it white and go back. This is the only sprite we are going to need. Now I'm going to write some scripts. I create a group for the scripts called graphics and create the first script here called graphics initialize. First of all, I'm going to define some macros. Graphics default drawing color. This will be the default color of all shapes. And graphics default growing alpha will be the default alpha of all shapes. Another macros will just specify some default values when rendering a pixel. The last set of macros will specify default values when rendering a surface. Now I declare some global variables. Using global variables is considered a bad practice, but some specific solutions require it. For example, the standard input-output library for C++ is using global variables as well. Now I create another 6 scripts that will work as setters and getters. These scripts will be setting or getting the values of the global variables I have declared. We take advantage of using global variables because it will allow us to call these scripts basically everywhere, so there will be no limits. Finally, I can start writing the scripts which render some shapes. First of all, let's create a script to render a single pixel. This script is going to be very simple, and I will just use the drawSpriteX function, and I will fill its arguments by the macros I define in the graphics initialize script. Then I will just create another script to render a single pixel, but now it will also allow you to specify the color and the alpha value of the pixel. To do so, you have to set the drawing color and alpha to the arguments that represent color and alpha, and then set it back. Another script will be used to render a line. As I said in the analysis, I am going to use the Bresenham's algorithm. First of all, I check if the x1 variable is equal to x2 and the y1 variable is equal to y2 as well. If all values are equal, I just render a single pixel, otherwise the program will enter the algorithm. I'm not going to explain how the algorithm works here, because it would take me a lot of time. Anyway, it works with so-called predictor, which controls what the algorithm is going to do and where the pixels will be rendered. Again, I create a similar script to draw a line, but now it will allow you to choose the color of the line. The third shape, the library is going to support are filled rectangles. I check if the value of x1 is larger than x2. If this statement is true, I must swap the values of these variables, so the value of x1 is always smaller than x2. Do the same for the y variables as well. Filled rectangles are going to be drawn as scaled sprites, so I have to calculate the scale. Then I just draw the sprite. The last script to render unfilled rectangles will be similar, but I'm going to work with a surface. I calculate the width and the height of the rectangle and get the surface with which the library works. If this surface is undefinite or it doesn't exist, I have to create it. Otherwise, I just resize it to the right size. I render a filled rectangle that is going to represent the border of the rectangle. If the width and height of the rectangle is larger than 2 pixels, I erase the inside of the rectangle and then just draw the surface. Because the library works with a surface, at the end I have to free the surface from the memory. So I create a cleanup script. Before I clean up the surface, I have to check if it's not undefined and if it exists, otherwise we could get an error. Let's create an object now and call it graphics. Inside the create event, I define some macros that represent colors and initialize the graphics extension. Inside the cleanup event, just call the graphics cleanup script. To draw some shapes, I go inside the draw event and call the scripts I have created. You can then specify your room settings as you want, but just place the graphics object somewhere. So that's all, and this is the end of the tutorial.